Warm welcome, everyone. Thank you for being here. Get yourself ready with a notebook. Grab a pencil or a pen. Whatever you choose to write with is fine. This is math from the void. It's math coming at you pretty much out of nowhere. Today we have a quick multiple choice question. It's going to be the MC Madness as we lead into the weekend right before the test. And I want to show you how to do a derivative of something like this, which looks absolutely gnarly. Give yourself about 2 to 3 minutes to try this on your own. Faster the better. And then you can unpause the video, come back and join us to see how we did it here. So this one has a pretty neat trick that isn't always recalled by students, but we want the derivative at a specific point x and y. This already suggests that we're going to need y involved in the derivative equation somehow. Otherwise, why would we need the y value? We would just need the x value. So the trick here is to use a logarithm. It seems like we have this crazy product rule on the right side, so we definitely don't want to take a derivative or try to open things up. It's just going to be a pain in the butt, and there are going to be a lot of opportunities to make a mistake if you do that. If you're so bold to try to do the product rule a bunch of times, and it's just going to take a lot of time. So instead, we can take a log of both sides. And remember that a logarithm of a product can be broken up. We can also make use of the power property of logarithms. So any exponents that are on these terms, they're really going to sort of go away, right? So this 2 is going to go in front. And we're going to have 2 ln of y equals, let's break this up, ln of x squared plus 2 plus, we can use the power property on that to say 2 ln of x plus 3. And I think you can immediately see how easy this is going to be. We're going to have plus 1/2 ln of 2x plus 7. Yes, this is going to be quite simple now. We can just take a derivative of both sides. Be careful here because you get 2 over y times dy dx. And all of these are fairly nice. So we're going to end up with 2x over x squared plus 2 plus 2 over x plus 3 plus just 1 over 2x plus 7. That's because the 1/2 is going to cancel with 2 from the chain rule. And it's very easy now to just plug in the point 1, 12, I believe it was. Yeah. So we can call this 1 over 6 dy dx equals 2 over 3. We're just plugging in 1. Very easy. 2 over 4. We'll fix that in a moment. And then 1 over 9. All right, so let's just multiply everything by 36. I think that's what I would do personally. Multiply everything by 36. Gets rid of the fractions. This is 2 times 12. This is 2 times 9. And this is 9 times 4. Sorry, 1 times 4. All right. 46 over 6, which I guess we can reduce down to 23 over 3. Now, if you wanted to, combine those fractions in a different way, if you wanted to get the same denominator, that's fine. I just chose to multiply by something which would cancel the denominator. I could have done 18, now that I think about it. That's why we had this additional factor of 2 to bring out. So if I'd done everything by 18, I guess that would have just been 3 dy dx equals 12 plus, 18 wouldn't have got rid of the 4. Not nicely. And then it would have gotten rid of that kind of nicely. Anyways, same idea. We end up with 23 over 3. And let's make sure that's one of the answer choices. Yes, it is. So it's 22 over 3. So if you screw up just a tiny little bit, you could get it wrong. All right, so that's a way that we can use logarithms to avoid having to use a product rule for differentiating. That's enough blab out of me here. See you guys next time in the void.